Now let's just see some of the terms which are related to the geometry. So let's just see the very first term, which is nothing but called as a line segment. So what is the meaning of a line segment, which is also called as a terminated line in terms of Euclid's definition? So this line segment is actually a straight path which is between the 2 points A and B. So as you can see from this definition, a straight path between the 2 points A and B is called as a line segment, and it is denoted by AB and a line above AB. It has a definite length with two end points A and B. So definitely a line segment do have a definite length, and there exist 2 points A and B. So let's just draw a line segment. This is nothing but a line segment having the 2 points A and B. It is nothing but a straight path which is lying in between both of these, and it is denoted by nothing but as AB and a straight line above. So it definitely has a definite length, and there exist two end points. We cannot extend it, so there exist only two end points over here, which is nothing but A and B. So this is nothing but called as a line segment. Let's just see the next definition or the next term which is related to the geometry, which is called as a ray. What is the meaning of a ray? A line segment AB, when extended indefinitely in one direction, is called as ray, which is represented as AB and above arrow. This is represented as AB above arrow. It has no definite length, definitely, because it is extended in an indefinite manner, so we cannot say anything about its length. So it has no definite length at all, and it has one end point only. So let's just draw the ray. This is nothing but the ray. As you can see over here, A is one end point over here, and it is extended from the point B toward this particular direction. So it definitely has no definite length, and this particular representation is nothing but of a ray, which is called as nothing but AB. So this is nothing but called as ray. Now let's just move on further and talk about the next term, which is called collinear points. Collinear points. What is the meaning of collinear points? Three or more than 3 points, they are said to be collinear if there is a line which contains all of them, or we can say that if 3 or more points are lying on a same straight line, then they are called as collinear, else they are not. So for an instance, if I'm talking about these particular 3 points, definitely these 3 points are lying on the same straight line, so it means that A, B, C, they are nothing but collinear. But let us suppose if I have these 3 points P, Q and R, I definitely cannot draw any particular straight line over here which can pass through these 3 points. So obviously these 3 points are not forming a pair of collinear points. So this is nothing but a representation of collinear points. So always remember, 3 or more than 3 points, they are said to be collinear only if there is a line which contains all of them. Let's just talk about the further term, which is nothing but called as intersecting lines. Intersecting means those which are intersecting each other. So two lines having a common point, they are called as the intersecting lines, and the point common to two given line is called as their point of intersection. So let's just draw the two lines. As you can see over here, we have the two lines over here as AB and CD, and both of them are intersecting at this particular point. So this point is called as the point of intersection. This O point is called as the point of intersection, and the two lines are called as the intersecting lines because they do have only a common point over here as nothing but O. So two lines have a common point or having a common point, they are called as nothing but the intersecting lines. This is nothing but called as the intersecting line. So let's just move on further and talk about the term which is called as the parallel lines. What are the parallel lines? Two lines L and M in a plane, they are said to be parallel if they have no point in common. If they have no point in common. So let us suppose if I am drawing the two parallel lines as L and M. So there is no point common in between these two lines because there is a lot of space. As you can see, the distance in between these 2 points from this particular point, from this point is same throughout the two lines. Moreover, we can say that if the distance between the two lines is same at every particular point, so these are also called as nothing but the parallel lines. So two lines, they are said to be parallel in a plane if they have no point in common at all, and they are denoted by a special representation L parallel to M. L parallel to M. So this representation is actually called as L is parallel to M. So always remember, what are parallel lines? These are nothing but called as the parallel lines. So let's just talk about the further type of lines which are called as perpendicular lines. What are perpendicular lines? Two lines P and Q which are lying in the same plane, they are said to be perpendicular if they form a right angle, means an angle of 90 degree, and we write them as nothing but P perpendicular. This is nothing but a symbol of perpendicular. P perpendicular to Q. P perpendicular to Q. So let's just see the two lines as this. We have P, we have Q, and both of them are forming an angle of 90 degree with each other. Right angle means an angle of 90 degree with each other. So whenever two lines, they are lying in a particular plane and they are said to be perpendicular to each other if they form a 90 degree angle with each other, or if they form a right angle. So as we can see, this is nothing but a right angle. So in between these two lines, if we have an angle of 90 degree, then they are nothing but called as the perpendicular lines, which are represented as P perpendicular to Q. So this is all about some terms which are related to the geometry. Now let's just move on further toward an example. So let us suppose we have an example which says, does Euclid's fifth postulate imply the existence of the parallel line? And we have to explain this. Obviously we do aware about the Euclid's fifth postulate. So let's just sort out the solution set, or let's just write the answer for this particular question. So first of all, it says that, does Euclid's fifth postulate imply the existence of the parallel lines? Yes, definitely. Yes. So the answer is yes. The Euclid's fifth postulate, do imply the existence of parallel lines. Do implies the existence of parallel lines. So it says explain. Why? So let's just explain it, because we know that if we have two lines, such that a line is passing through the two lines, and if the interior angles made by this line with the other two lines on the same side is 180 degree, then if the two lines extended on that particular side, then there will be no point for their intersection. Or we can say that, or they will be parallel. What does it mean? It means that according to the Euclid's fifth postulate, let us suppose if we have this particular line, and if we have this particular line, let us suppose this particular line So according to the Euclid's fifth postulate, let us suppose if I am drawing this particular line as in this manner, and I'm taking this line as nothing but a line which is falling on these two lines such that their interior angles, let us suppose if I'm taking it as angle 1, if I'm taking it as nothing but the angle 2, I'm taking it as nothing but the angle 3, further I'm taking it as nothing but the angle 4. So if the angle 1 plus angle 2 is nothing but is equal to 180 degree, and if the angle 3 plus angle 4 is nothing but is equal to 180 degree, then if these two lines are extended on particular one side, then they definitely would not meet each other at any particular point. Furthermore, if I'll extend these two lines from this side, then they definitely would not meet each other. They will remain parallel to each other because the interior angle sum is nothing but is equal to 180 degree. So according to the Euclid fifth postulate, we can do say that there is an existence of parallel lines if we are talking about all these conditions. So this is all about the example number 1, and this is the end of our chapter, which is nothing but called as the introduction to the Euclid's geometry. I hope all the concept related to this particular chapter is all clear to you.